Welcome to the second of a series, Demystifying Pointers in C. Today we'll look at two ways in which functions can be called and why would there be a need for pointers. I'd like to first tell you what happens in an assignment statement. Consider this initialization statement where a variable is assigned a value during its declaration. It is saying that L is a character, which means it will require a byte of memory, and will be assigned the character L. Value on the right will be stored in the variable on the left. The ASCII binary representation for the character L will be stored in the 8 bits allocated for L. Let's declare another variable called M, which is a character. So another byte allocated for M. Assign L plus 1 to M. The value on the right is obtained and stored in the variable on the left. So evaluating L plus 1, bringing in the value of L, adding 1 to it, and storing it in M. An assignment statement in C is only valid if the types on both sides of the equal sign are the same. Now, let's look at how function calls happen in C. Consider this snippet of code. We're saying we need two ints A and B, 10 in A and 32 in B. Then we're calling a function swap with the arguments A and B, which means the function swap should have two int parameters. So whenever swap is called, there will be two ints x and y created in memory, and behind the scenes the arguments are assigned to the respective parameters. So A will be assigned to x and B will be assigned to y. This is the case with every function call. Arguments are always assigned to the positionally respective parameters. So x will be 10 and y will be 32. This method of passing variables to a function where the values of arguments are copied into parameters is called a pass by value. Let's get inside the function and see what's happening. It's initializing a local variable called temp with the value stored in x. So 10 will be stored in the new 4 bytes allocated for temp. Assigning the value of y to x, so x will have 32. Assigning the value of temp to y, now y will have 10. Cool, we did manage to swap the values of x and y, but that was not quite what we intended. We had to swap the values of a and b, not x and y, but the function had no idea about them. As their values were copied into the parameters x and y, a and b had no existence for the function. This scenario where we intend a function to manipulate the variables that are outside of it can be tackled by passing not the value but the references to variables. And a reference to a variable can be obtained by using the ampersand or the reference operator. Ampersand A and ampersand B will give me their references. Now, I'm passing the references to these ints, which will usually be big numbers represented in hex digits, but I'll just stick to using these colored boxes. This method of calling a function with the references to variables is called a pass by reference. Now that we are passing addresses to ints, the new swap function should take two int pointers as parameters to be able to hold those addresses. Whenever this function is called, memory is going to be allocated for the two int pointers, x and y. And just like before, the arguments will be assigned to parameters. We made sure that these assignment statements will be valid by making the function have parameters capable of holding addresses to ints. So x will contain the address of A and y will contain the address of B. The insides of the function will have to change a little bit so that we don't just end up swapping the contents of x and y, but the contents of variables that x and y are pointing to. We'll need a temp variable to hold the value of A, but the function directly doesn't know about A. But it does know the address of A through x. We access the value at an address stored in a pointer by dereferencing it using the star. So this will go and fetch the value in A and put it in temp. At A, we need to store the value of B. Again, to get the value of B, we dereference y, that's pointing to B, and assign it to not x, but the variable pointed to by x. So star x equals star y. This is going to put 32 inside A. Now we need to access B by dereferencing y, store inside it the value stored in temp. Great. We managed to write a function that could have an effect on variables that were not a part of the function using pointers. This is a typical use case where pointers can come in handy, where there's a need for a function to be able to manipulate or have an effect on variables elsewhere. That's about it for this one. Thanks for watching.